Assalamu alaikum. My name is Talha Umar. Today I will explain the line follower robot that we made in our semester project in MES microcontrollers and embedded systems using Arduinos using microcontroller. First of all, I'll introduce my group members Daniel Aslam, Sayyid Mohsin Arif Kazmi and myself Talha Umar. First of all, introduction. What is line follower robot? A line follower robot is a robot that follows a straight line. It can be a white line, it can be a black line, depending on the condition provided through this through to the um, to the AVR. First of all, we made a project we made a line follower robot with multiple sensors such as ultrasonic sensor, color sensor, current sensor, voltage sensor, etc. We aim to create a smart robot that follows line, avoid obstacles, and recognize colors. To avoid obstacles, we use ultrasonic sensors, and to recognize color, we use color sensors. A robot, a robot uses a QRT sensor for tracing line. For basically a tracing line, we use IR sensors and RO sensor to detect obstacle. To detect obstacle, our SRO7 means ultrasonic sensor and TCS3200 sensor to identify colors, basically a color sensor. To control robot movement, we are using a L298 motor driver, and for wireless communication, we are integrating an ESP module. Our project will involve setting up hardware, writing software, testing and systems, and documentation the process. By the end, this robot will demonstrate the practical use of embedded systems in the various tasks. This is our timeline span was 8 weeks. And this is how we create our project and how we divide the work division. First of all, initiation feasibility, work breakdown structure. A line follower robot. What is LFR? Develop basically we develop core functionality using IR sensor, L298 motor driver, and Arduino Uno. Basically, we first of all we just follow initially made a robot that just follows a straight line. Then we made a PCB fabrication design and fabrication of PCB for compact integration of all components, obstacle avoidance. Then we add ultrasonic sensor, color sensor in the line follower robot that are already working, that we have already in working state. Encoder module and power management, wireless communication setup. For wireless communication setup, we use ESP32 module because we all know that ESP has a built-in Wi-Fi module and Bluetooth module, so that's why we use ESP32. Final testing and demonstration. Conduct comprehensive testing, optimize parameters, and showcase using SD card to store path and other necessary informations. Chapter 2, Project Conception. First of all, introduction. In the age marked by civil technology progress, the combinations of embedded systems and robotics has unlocked possibilities for crafting intelligent and adaptive machines. This is all the introduction of this project LFR, where it is used. As we explore the depth of our project's development, the aim to showcase the seamless integration of state-of-the-art components. This includes color sensors, ultrasonic sensors, and ESP32 module microcontroller. The genre, this genre, our creation more than just a technological marvel stands as a testament of the potential of embedded systems in robotics. It is a future where the intelligent machines effort interact and understand their surroundings. First of all, list of features and optional specifications of our project. List of features and optional. First of all, basic features, sensors. Sensors are high resolution sensors for precise line detection in various environmental conditions. Ultrasonic sensor module. Ultrasonic sensor basically measure the distance with a rapid response for effective obstacle detection and avoidance. Color sensor is a versatile color detection with a programmable light to frequency converts for accurate color sensing. L2 line 8 motor driver. Dual HBG motor driver enables precise control of robots movement and turns. Arduino Uno. We use microcontroller board provides a feasible and user-friendly platforms for program execution. Encoder modules provide motor rotation data for feedback, aiding in precise control and navigation. PCB fabrication in PCB is customized printed circuit board designs, optimizing space and minimizing wire connections for the compact design. Basically, PCB fabrication is very important in every project. In PCB, we can reduce the wire connections that we basically use it in this project in this LFR. The connection when we use PCB, the connect as the wire are less. If the wires are more than we cannot if there is a bug creates and we cannot recognize where this is generated. Robot chassis sturdy and customized frame providing a foundation for components integration and mobility. Battery and motors power source tolerated for motor operations, ensuring reliability and efficient energy supply. Operations: the basic operations of a line follower are as follows. Line follower algorithm: an algorithm implemented on an Arduino Uno processes the sensor data, making real-time decisions based on the position of the robot related to the detected line. Motor control commands: the Arduino Uno sends commands to L298 motor driver, distinctly the speed and direction of the robot's motor in response to the line following algorithm. Directional adjustments: depending on the sensor readings, the robot adjusts the speed of individual motors, enabling precise turns or connections to stay aligned with the line. Proportional control mechanism ensures that the robot responds smoothly to variation in the line, preventing abrupt movements and promoting stable line following. Real-time adaptation: the line follow process occurs in real time, allowing the robot to adapt swiftly and change in the track layout, including sharp turns in or intersections. The components that we use in our LFR is Arduino Uno, Arduino Uno robot chassis, L298 motor, 3 to 4, 3 volt to 6 volts, 12 SIM module for LCD display or OLED display. We use OLED display in this case. Jumper wires, header pins, SD card module to store data, resistors, capacitors, IR sensors to detect the line, on off button switches, ultrasonic sensors to measure the distance, encoder, L298 motor driver, voltage sensors, a rechargeable battery. We use in our case we use three rechargeable batteries of 3.7 volts. One current sensor ESP32. ESP32 for Bluetooth module to show as we can see here. This is the output when we connect to the Bluetooth module through the mobile app. Here the readings that we have: voltage, current, and color. This is all the readings. OLED display to display the what we want to display. Shield PCB board and color sense. Project development process. First of all, conceptualization and planning. Everything is done through the planning. Define the project scope, objective, and key functionalities, outlining a clear roadmap for development. Design and prototyping. Develop detailed designs including hardware schematics and software architecture. Create prototypes or mock-up to validate concepts. Components acquisition and integration. Acquire necessary components and integrate them according to the design specification, ensuring capability and functionality. Software development: write and test the software code in incorporating algorithms for various functionalities, debug and optimize code for efficient performance. Testing and validation. Conduct comprehensive testing for individual components and the integration system, addressing an issue and ensure that the project meets predefined objectives. This is all the objectives. Chapter 3, Project Design. The design of our project is carefully carved, integrating cutting-edge technologies into the sleek and efficient package. This is the project design. We have introduced that we use color sensor, ultrasonic sensor is ESP32 module for to display for Bluetooth connection. Arduino Uno IR sensor to detect the light. All is given in this in our project design. System consideration for the design. Make sure all the parts of our robot work together smoothly in a big deal. Yes, as we have done that, first we basically follow just a straight line. Then we add all the components as ultrasonic sensor, color sensor, OLED display to avoid ultrasonic sensor to avoid the obstacle. First we just follow the straight line by our robot, then we add all these components. Keeping our robot running smoothly for a long time means managing its power well. Yes, it's a power how we provide the power supply. We are using buck converter to make sure that the ESP and Arduino Uno get steady power so that they do their job reliably. Picking the right batteries for the motor is also important to make sure our robot is an efficient and possible. This is all the system consideration for the design. Next, pinning. This is how we use the pinning. First of all, VCC. VCC 5 VCC the 5 volt source, and then trigger pin, echo pin of ESP. Chapter 4, Mechanical Design. Mechanical selection. In the process of selection the appropriate mechanism of our project, we extensively refer to the document USA Tech. This is all. Mechanical selection and platform design. Chapter 5. Chapter number 5, Electronic Design and Sensor Selection. We use ultrasonic sensor because it is necessary. Our supervisor advised to use all these sensors, just like ultrasonic. This is ultrasonic sensor. What is ultrasonic sensor? Explore ultrasonic sensor basically measure the distance. This is an ultrasonic sensor. The pinning there is a this is the pinning ground, echo pin, trigger pin, and VCC of 5 volts. It also works on 3.3 volts ultrasonic sensor. This is Arduino Uno. This is the pinning. This is the USB plug and external power supply. TX, RX, all these are Arduino pins. Arduino Uno built around at Mega 328P microcontroller. This is a microcontroller of at Mega 328P. Stands as a versatile, unfriendly development board with a set of 14 digital pins and 6 analog pins. The various power inputs. It facilitates seamless integration and control the external components. TXRX pins. TXRX pins are basically the receiver and transmitter pins. When microcontroller's operation involves bitwise manipulation and a binary level gathering, user precise control over an individual bits using registers. Arduino Uno, a powerful platform for diverse range of embedded system projects. Then L298 motor driver. L298 motor driver. A motor driver is a versatile dual H-bridge motor driver IC. This is basically a H-bridge circuit, and this L298 motor driver is connected through the two motors that we use in our robot, and this is an array of IR sensors. This is the pinning output. These are the outputs: 5 volt input and the ground. Infrared sensors are commonly used in line follower robots to detect a presence or absence of a line on a surface. Here's how an IR sensor works: is simply a line setup line that's typically used in basic line for robot. Infrared light illumination, light reflection and detection. This is all how the IR sensor works. Infrared light emission, light reflection and detection. It basically works on the principle of reflection. Reflection and transmission. Detection. Signal processing determine the line position. Color sensor. This is the color sensor. This is the pinning ground output, VCC input and ESP32 and a Wi-Fi modules. As we all know that ESP has a built-in Wi-Fi module and Bluetooth module, so we use ESP32 because we need to display the data that we like current, how much current or on how much current does the our project works or in a working state, on which current it is working, on which voltage, on which what the color it is sensing, on what distance the obstacle is placed. All these we have to display this on the Bluetooth, by using Bluetooth on the mobile or on the OLED. So that's why we use ESP32. ESP32 is a versatile microcontroller known as built-in Wi-Fi module and Bluetooth capabilities, allowing it to connect to the internet and other devices wirelessly. SD card reader. We use SD card reader to store our data or path. And OLED display. OLED display uses the to display. It is an output device that we use in our project. Then systematic and PCB. This is the PCB of our systematic of our design. This is an ESP connections, and this is the how we connect. This is the PCB design. The block diagram. Ultrasonic sensor and IR sensor gives the input to the Arduino Uno, and then Arduino gives output to the L298 motor, which gives to the motors, left motor, right motor and other motors. Then ESP32. ESP32 OLED display. Current OLED display is the output of ESP32. Current sensor, voltage sensor, SD card reader, this motor speed, this all the inputs of this ESP32, and the output of this is ESP32 is the OLED display on which it displays the data. Chapter 6 is the hardware, controller selection and features. Arduino Uno controller, microcontroller powerhouse at Mega 3.3 to 8P. Microcontroller provides a balanced blend of computational power and user-friendly simplicity, creating on to both noisy and experienced developers. Versatile pin configuration. This is all we use in our project. We have done in our project. Software design details, algorithm framework, sensor integration. How the sensor integration means how the sensor work, how the sensors integrate. Then line follower algorithm, obstacle avoidance algorithm, ultrasonic detection, how this ultrasonic sensor works, functionality, modularity and feature enhancements, how the feature enhancements, how the further enhancements can be done in our project for optimization and testing. State machine. This first of all, this is the read line. In our project, this is the first, if the motor has to go to the forward, the reading, uh, the IR sensor detects the right and it sends reading to this. If it comes to true, then it will come to the forward. If line if the if it has to line detect to the and is moving to the left, then this is true and this left machine is moved, and this is all how the machine works, state machine works. Conclusion: in our project, we are successfully design and implement a multifunctional robot capable of following right or avoiding obstacles, monitoring motor speed, and providing real-time feedback on system. This is all how it works. system integration, software development, integration of additional sensor, data display and storage, testing and calibration, final adjustment and demonstration. Now this is the PCB design. The ESP32 module connected, Arduino Uno, LT98 motor driver, and this here we can see that this is our final project simulation. This is LT98 motor and chassis. These are the motors. Here we use this ESP32, and there it is the Arduino Uno. ESP32 for current sensor. This is current sensor. This is voltage sensor. This is OLED display to display the data. All for Arduino Uno just for L298 motors and ultrasonic sensor and color sensor. Here this is the connection of this ultrasonic sensor and color sensor IR sensor is there. This is our final project simulation, and this is all for our project. Here you can see the other picture of